Hello everybody. Thank you for joining our webinar on building social inbox with MongoDB. I think we'll wait for a few more minutes before we start so that we give some more time for the last minute participants to log on. Okay, good morning to everyone present here. Welcome to our webinar on building a social inbox with MongoDB. I am Mukta Ashok and I will be your moderator for today's webinar. Now, before we begin, let's review a few pointers on how we can interact during the webinar. Now, we are looking at the attendee interface of GoToWebinar. The viewer window on the left will allow you to see everything that we will be sharing on our screen. And the control panel at the right is how you can participate in today's event. We would also like to hear from you, so please do ask questions and share your comments during the webinar. Now, this option is located on the left-hand side tab. Now, we will be reviewing your questions as they come in and we will take them up in the question and answer session towards the end. Also, the webinar is being recorded and everyone will receive an email with a link to view the recording of today's event. Finally, I want to ask you to please complete a very short feedback form that will be online after the webinar. It won't take long and your feedback is very important to us. Now, as we move on to the webinar, I would like to introduce you to our company, Suyati Technologies. Suyati basically focuses on delivering niche IT solutions and services, including CMS, CRM, and e-commerce. We are an Electron featured implementation partner, a Microsoft Gold partner, and a Salesforce App Exchange partner, with an extensive experience in .NET, open source, and mobile app technologies. Speaking about our expertise in free and open source technologies, we have 5+ experience in design, development, and deployment of complex open source. And we have seen a gamut of successful projects, which would include a conference app, a job placement portal, an amusement park management system, etc. Now, at this point, I want to introduce you to our featured speaker, Krishnanuni, a technical architect at Suyati Technologies. His focus areas include real-time analysis of big data and scalable web applications, a frequent speaker at free and open source meets, and he is well-versed with conducting workshops on mining data from Twitter using CouchDB and Node.js. And he is also conducting workshops on rapid application development using Python and Qt. Please do feel free to post questions, follow us, or even tag us. You can use the hashtags and handles that you see on the screen. Now, I'll walk you very quickly through the agenda of the day. We'll start out with an introduction to MongoDB, and we would speak about social inboxes and what are the different types of social inboxes, followed by challenges in building social inboxes, patterns of building social inboxes, and then we'll be implementing a write-intensive social inbox. And finally, we would conclude with introduction to Mongologue. Now, I would like to pass on to Krishnanuni.
Hello and good morning to all of you. So I'll quickly start my session by an introduction to MongoDB. Before that, I would like to thank Mukta, moderator, for the very generous introduction she gave me. So about MongoDB. So MongoDB derives its name from the word humongous data. So as the name signifies, MongoDB is all about handling large volumes of data. It's oriented towards performance, availability, and automatic scaling. Those are the key points that make MongoDB a spectacular choice if you want to write an application that needs to be scalable and needs to work with a lot of data. You can find MongoDB for all platforms under mongodb.org/downloads. They are released as open source under the NGPL license. You can also try out MongoDB online using try.mongodb.org. You can find extensive documentation on MongoDB within their website, docs.mongodb.org/manual, and also a lot of community support on all the major platforms like Stack Overflow, just a lot of user groups on Google, etc. So just to give you an idea about how MongoDB differs from traditional relational databases, MongoDB is basically NoSQL. it does not work like a traditional relational databases. MongoDB stores all its data in the form of documents, which are like structured to look like JSON arrays, even though they're stored as BJSON or binary JSON at the backend. All the data is stored as documents in MongoDB as JSON arrays. So you can see the example here where you can see that one document about a user here, where we have a name and age, the status, groups, etc. They're all field value pairs which go into a JSON array kind of document. And we can also have a field value pair where we have a document embedded within another document. So MongoDB has no restrictions. It's all up to your imagination. There is no fixed schema about how the document should be structured or what goes into a collection, etc. It's all depending on the data that you have. You can put it in as documents as in how you need it. MongoDB stores all documents in collections. Collections are logical groups of documents. You can relate them with tables in relational databases. So if you relate them that way, then collection would be tables and documents would be records, and each entity within a document would be a field. So collections can be a group of users, a group of letters, a group of anything that can be logically grouped together. Again, there is no restriction that each document in a collection should be of the same format. They can differ in format, again, as in how the application would require its data. Now, coming to today's major topic about building social inboxes, I'd like to quickly speak about what is a social inbox. So, we've all seen social inboxes. We use examples of it every day, starting from our email, our Twitter home, the Facebook newsfeed, etc. Everything is a social inbox. Basically, it's an inbox where all the people on your social graph, all their posts show up, all the data that they pump into the system show up. So it can be a Twitter newsfeed, it can be your email, it can be your Skype chat, it can be anything. So now you see applications these days which revolve around social inboxes quite a lot. There are a lot of social networking applications, mobile apps, etc. available nowadays. So this session is about how to build a very scalable and a very quick implementation of social inboxes using MongoDB. The considerations that go into building a social inbox, majorly two of them are there. One would be the write and read requests that would go into creating a social inbox. The sheer volume of the data that would be pumped into an inbox that would go into a social media system would be huge. You can imagine, since all of us these days use Facebook and Twitter, we can imagine the kind of volume that social media network would have to deal with. So the performance and the volume of data is a huge consideration when you think about designing a social inbox. And also, we need to keep a very real-time user experience. So that means if a friend of yours is creating a post from the United States of America, you need to get that in China immediately, as soon as possible. So the real-time user experience has to be maintained. So these are the major considerations that need to go into when you create a social inbox. Let's examine what a user would do in a system that has a social inbox, per se any social media. He creates posts, he reads timelines, he follows other users, he can get followed by other users, so other people need to read his posts, etc. So all these constitute a lot of data going hither and thither. All these require a lot of operations where you move data from one place to another so that it's available to everybody. And again, keep in mind that this has to be done as real time as possible without affecting the performance of the system at all. Let's see what an inbox does. So for an inbox, we have, like I said, a real-time read and write. So we also have sorting of posts, like you might need to have posts that are the most recent at the very top. You might want to sort them in order of the friends who have posted them, etc. So there is a lot of sorting going there. So there is a lot of paging and delivery. So you cannot. So let's say you have 100 friends and all of them post at the same time. You cannot have all that data pumped into your inbox at the same time. So you need to be able to page through them, and so that it's readable for the user. So the inbox has to give that, has to keep in mind that there's somebody who's reading the inbox, somebody who's actually interacting with it in real time. So the data cannot just be pumped into it. So we need to be able to page it and deliver it in a timely manner. Just to give you an idea of what we're talking about, an average tweet on Twitter makes it to about 254 inboxes. So that means in Twitter, in a network like Twitter, a user would have on an average about 254 followers who would be required to read his post. So any tweet that you make, any post that you make will have to be delivered into 254 inboxes at the same time. That's just to give you an idea about the scale that we'll be working with. So the myth of normalized data. So in a situation like this, we will have to throw out all our legacy ideas about data and how normalized data will help us and how duplicacy is a bad thing, etc. We'll have to throw all that out the window to make this performance possible. So we need to have a lot of duplication introduced into the data for performance. So that means you need multiple copies of the same data so that you can deliver them on a real-time basis to all these inboxes at the same time. And we need to have a lot of parallel copies also for scalability. So that means we need a lot of horizontal scalability also possible within our database to make it extremely scalable and have a high performance. So some schema designs. So there are some techniques that MongoDB talks about and has been debated about online for designing a schema for such an inbox. So three of the techniques that they have, one would be fan out read, one would be fan out write, and this third one would be fan out write with buckets. So ideally fan out write with buckets is the best way to handle this, but it's also a very complicated way, so we will not go there. We will keep our implementation around fan out write, but just to give you an idea, let me tell you about what fan out on read is. So fan out on read is that this is the difference between fan out on read and fan out on write. So on fan out on read, the data will be kept in one place, and all the people who are reading that particular post will have to come to that place, fetch it, and read it. The good thing about that is the send message is very efficient because you only keep it in one place and there is no fan out. The read is the worst with that implementation because all the people would have to find this one particular record out of all the records that are there, which might be in any shard on any server of your system. So since there is only one copy, all the queries would have to be routed to that one copy. So the performance for reading the post would be the worst. The data size is good, it's the best because the message is stored only once. But let's check fan out on write. So fan out on write, what happens is when you create a post, a copy is kept for each user or for each inbox that would actually have to read it. So that means that inbox would have easy availability of that particular post, which makes the which makes the read very efficient. So because the inbox would have easy availability of that post. The write is also efficient because you can have a shard per recipient. A shard is like a replica or one instance of the MongoDB, a small subset of the data, a whole database for each recipient. We'll talk about sharding a bit more in detail a bit later. So the write performance is also good. The data size unfortunately is the worst because it keeps a copy per recipient. Unfortunately, that's one of the things that we would have to live with for our high performance. So for all inboxes, all social inboxes, reading and write performance are very important. So we have to go with an implementation that gives you more or less the same performance for your reading and writing. So hence the reason that we've chosen fan out and write. So let's get started with some code. So to get started, we will just create some users initially. So if you can see the code here, yeah, if you can see the code here, you can see how we easily create a user on a MongoDB. So for those of you who really want to try it out, MongoDB offers an online editor where you can try out all your Mongo code, just enough to scratch the surface, as they say on their website. So it's a very simple editor. You can start out by, let's say, creating a user. So it behaves exactly like JavaScript, so there's nothing much you have to be worried about. So let's say we're going to create a user called John, and John will be given an ID 2, and John's age is 24. So this is John, and we will add John into one of our collections. So let's say so if you don't already have a collection, Mongo will create it for you. So we're going to create this collection. Right. So now the user is inserted into that collection. So let's just try to find them. So we're trying to find all users in that particular collection. And then we have it. So we have one object in our users collection. So Mongo has assigned an object ID to that particular collection. So you can see a random 16-digit, a very long object ID there. So that's assigned by MongoDB. It will be unique. We do not have to worry ourselves with that. Yeah. So that's how you insert and figure out users in the system. So before we go further, let's we've already talked about schema. So let's talk about how our particular database schema would be for a social inbox. So like I said, just to remind you, these are the things that a user does. He creates posts, he reads timelines, he follows other users, he gets followed by other users. So this is just a reminder of all the things that a user does. So how would we structure a user document? So we need at least these informations. We need to know the name of the user or the handle of the user. This is a bare minimum implementation, so we need that. We also need to know who his followers are, and we also need to know who he is following. So you can just keep the example of Twitter in mind here. So we need at least the Twitter handle of the person. We need to know at least who are the followers so that we can fetch the posts from those. We would need to know at least who he is following so that we can fetch the post from those people and put it into his inbox. We would need to know who are the followers of John so that we can fetch all the posts of John and move it to their inboxes. So let's just go ahead and create another user. let's say that John is following Doe here. I'm sorry. Yes. So we have created that user document. Now let's try and save this. So that insert has successfully completed. Let's try to find let's see all the users in that collection right now. So as you can see, we have two objects in the user collection, or we have two documents in the users collection. So one would be John and the other is Doe. And we now see that John is following Doe. So as you can also see that the structures of both these documents in the same collection are different. So like I said earlier, Mongo has no restrictions on what the structure of a document should be. So let's think about a post. What makes a post? So we need to know at least who created the post. So that would be from. We would need to know on what date or what time this particular post was created. So we have a date field. We would also like to have a message, obviously. So we have a message field, that's hello. So let's create a post now. And we will save the newly created post into the posts collection. So that has been successfully inserted now. Let's try and retrieve that. So we can now see that the post is created, and it's created on this particular date. We have the timestamp there, we have the date and the time, and we also see the message and who has created the post. So we've just created a post now. So from a post, we can try and retrieve the user who has created the post. So let's try. So we have the post here. This is the particular post, and from this post, let's try and retrieve the user who has created this post. So you can see how the query is formed here. So you can see that the DB, we're querying the DB to find one particular, or from the users collection, we're trying to find one particular user whose name is actually the name of the person who created the post. So we're running the query now. So Yep, I'm sorry because we just created John to have caps in his name, so we might need to change that. So let's add another post. And this is our new post. Let's save this post. Now let's try to do the earlier query again. Yes. Now it retrieves John. So John is the person who created that particular post, so we've retrieved that from this collection. So now we have the next operation that we would need to perform when we actually create a post is that we would need to put all the copies of this post into each follower's inbox. So let's say that Do, in our earlier example, that Do is creating a post. So let's create a new post for Do. Do has created a post and he says hello John. He says hello John. So that post is saved. So now Do has created the post and we know that John is following Do from our, that's how we set it up. So we need to retrieve all the followers in that particular user. So let's retrieve Do. So now we have Do and we know that Do has these followers. Do is being followed by John. And then we try and iterate through each follower that Do has. We use a loop and we iterate through each follower that Do has. And we can set another value to that post, to the copy of the post that we're trying to create, where we have the follower's name. So we need another collection called inbox. So first we create another field. I'm sorry, unfortunately it seems the connection was kind of lost in between. So for those of you who didn't hear me, we're just trying to look through Doe's followers here, which is John, and when Doe creates a post, we will try and move to John's inbox. So let's create a copy of that particular post that John created. And we will add another field to it called to, and we will say that John is the person who has to receive this particular post. So now if you look at post, you can see we have the from, the date, the message, and to. Then we just move it into our inbox collection. So let's see what our inbox has to say. So it has the copy of the post that we created just now, where we can see that the date, the to, message, and from. So message has been created from Doe to be sent to John, where the message is hello John. So now how do you retrieve the post? So all this goes into the inbox for each person. And we now need to figure out all the posts that John has to receive. So when John is trying to read his posts, he will try and retrieve those posts. So for John, so let's say these are John's messages. So all the messages that are marked to John, all the messages that are marked to John will now be retrieved into John's messages. So you can see that John's messages now have that one particular object which was retrieved. That one particular object is the ID, that one particular message from Doe to John. So we've retrieved all the information for John. So if you have multiple posts in that particular inbox, we can retrieve all of them in one go. So for each time John tries to read his inbox, we can easily retrieve only the messages that are marked for John without actually going through each post and running any conditions against it. Everything that's marked to John, which is a direct operation, will be retrieved immediately in one go to be moved to John's timeline. We can also sort the posts by the date on which it was sent according to date, so that the latest ones are retrieved first. We can also limit them. We can also only retrieve, let's say, five of them or 10 of them. We can page using let's say the last retrieved ones. So let's say we retrieve 10 in the first go, then we can retrieve the next 10. So we can write queries using the query language for MongoDB to retrieve posts in any order that we want. But the good thing about this is it need not apply any other conditions to actually search for the posts, because all the posts that are marked to John will have that one field which is marked to John. Let's talk about shards. So you might be wondering that how this would actually impact any performance, because we have just one collection where all the inboxes are going to. So even if it's a relational database, I can just have one field that says to, and I would get almost the same performance. But this is where the automatic scaling capabilities of MongoDB come into play. So Mongo has this automatic ability for horizontal scaling. So you can create shards of the same database where you can split that database based on certain keys. So let's say we have the inbox collection. We can split the inbox collection into multiple horizontal servers, or more horizontal shards as MongoDB calls it. You can split them into horizontal shards where you can use any shard key to actually split it. So let's say we shard a collection. So in our case, it would be the inbox collection, and we would shard it based on who was sent, to whom it was sent, and you can either split it on the to field, you can split it on the from field, you can even split it on the date field. So you can split it on any one of the fields that you want to make sure the availability is there, so that Mongo would automatically just search in that shard. It would not have to look through all the information in the rest of the shards. So if you split according to the to field based on who that post was marked to, all of John's posts would be on one shard. So Mongo would know that that's the shard that I have to look at. I don't have to look at all my other shards where the posts for other users are there. There's no filtering happening. It can just directly go into that shard, making all the search much more efficient and much more quick. So that's how we leverage the automatic scaling capabilities of MongoDB, and we just look at each shard. So this is one capability that can be used in a lot of scenarios, because you can specify the shard key, the key on which you need to split all the data up. So all the posts, so if you're splitting the inbox collection, all the posts that have that particular key will be moved into one shard. And if you have a multiple instance of the same key, let's say the 2 is marked to John, the 2 is marked to Doe, the 2 is marked to Jane. So all three of them would be moved into 3 separate shards, where all of John's posts would be in one shard, all of Doe's posts would be on the second shard, all of Jane's posts would be on the third shard, and Mongo would automatically know when the query comes in which shard to look at. The developer or the database administrator would not really require, or the code, the application would not require to have any logic to actually test, actually look at that particular shard. It's automatically maintained by the MongoDB server, which is what actually makes Mongo an awesome choice for this kind of application. So now to go further, we have a lot of other things also that would be required to actually build in all the features that a social media app would need. So you would need groups, you would need to follow, unfollow, you would need other media in the post, you would need comments, likes, etc. So this is where one of the frameworks that we've built, we call it Mongologue, that comes into picture. So Mongologue is available publicly right now on GitHub. It's a framework that we built on PHP, which would help you to set up your own microblogging client easily using MongoDB. So all the hard work of sharding, managing shards, the collections, the schema, the fan-out-write implementation, etc. have already been done by Mongologue, and Mongologue provides you models where you can just easily use them. So for all PHP developers out there who use Composer, you can just add Mongologue into your application using adding this to your Composer file. So you just say Suyati/Mongologue and the develop version, because right now it's under development, and it would automatically come into your application. Then you just initialize Mongologue using the Mongologue factory. You create a factory, and then you create a new Mongologue, and you specify where your MongoDB server is. So all the sharding, etc. can also happen on the server. You can just create shards, and Mongologue would know automatically to work with it, but because again Mongo takes care of it all by itself. The code does not have to know. So you specify which Mongo database is being used, and you create a Mongologue. Then you can just go ahead and add users, anything you want. You can have handles, emails, first name, last name, any other information, and you just register that particular user on Mongologue. So Mongologue provides all the models that you would need, like the user model. So if you go a bit down, you can see the post model. So when you create posts, you have to have the user who created the post, the time on which it was created, any message, if there any category if to be assigned, or any other data that you want. and you can also add other files. So you can have images, you can have other resources, you can have links, videos, anything you want on the post, and the Mongologue post model would handle that. So you just create a post, and Mongologue would automatically figure out all the followers to whom this particular post should be delivered to, and move the post into those users' inboxes. You can create groups, and you can have users join the group. You can follow other users, you can follow groups, you can join groups. So Mongologue basically is 100% unit tested. So if you look at the unit tests for Mongologue, you can find the complete specifications for Mongologue here. So it's completely unit tested. So we have integration tests that will tell you about the complete specifications for MongoDB, and we have for Mongologue, and we have 100% test coverage. We also have unit tests, and it's available publicly right now on GitHub. We've released it on GitHub as open source. So, and it's also available through Composer, where it's released publicly again, and it's under the Travis CI, so you can always check for the health of the package. Any questions?
So yeah, thank you, Uni. It was a pleasure to have you on board, and thank you for an informative session. And folks, now we are ready to address your questions. Feel free to shoot your questions. You may type in your question using the question feature on the GoToWebinar. Yeah. Moving on to our first question, I will be speaking out the question, and Uni would answer it for you. The first question is, can you tell me some of the players who uses MongoDB?
Well, MongoDB has been recently adopted by a lot of big players in the industry. So CNN uses MongoDB for their CNN.com TV. Foursquare also uses MongoDB. iBible uses MongoDB. I think Justin.tv also uses MongoDB.
Okay, so we have our next question. Should I use MongoDB for banking solution?
Not really recommended, because banking is has a very transactional nature, and it requires a lot of. It's more suited to be built with a relational kind of, because the data is structured and the structure is all in place. So it's more suited to a relational kind of pattern. So not really recommended. Mongo would be more used where you have a lot of different types of data that can change, that needs to have a lot of flexibility, like in social media, etc.
Okay, so we have our third question for the day. Will increasing the nodes in Mongo improve the read or write?
Not really. There are other frameworks that does that, but not increasing the modes. It will not really improve the read and write. But having said that, increasing the number of shards in MongoDB, as you've just illustrated, would really help with the write and read performance.
Great. Fourth question. MongoDB is written in. Okay, what is MongoDB written in?
MongoDB is written in C++, and it has drivers on all the major languages. I think there is another question about whether any C# library is available. So MongoDB has drivers / libraries in all the major languages. So it has Python, it has PHP, it has C#, it has .NET, etc.
Okay. So we have next question. Let me know that can we convert the relational database to MongoDB?
Yes, there are tools that do that. QueryMongo is one tool that does that. There are also other tools available. We can just search. The MongoDB site has a list of a few.
Okay. How about associating with ASP.NET project?
It would be a great idea, but the first thing that you would have to figure out is the nature of the operations that you have to perform on your data. Like I said earlier, banking solutions or very relational legacy applications may not be the best suited to be moved on to MongoDB, but applications like social networks and maybe recommendation engines, data stores, data harvesting, etc. would be the best option. Associating with an ASP.NET project is a great idea. Like I said, banking solutions, etc. might not be, or the legacy relational database kind of applications might not be the best idea. But applications like social networks, recommendation engines, data harvesting projects, data modeling projects, etc., would be a great thing to implement on MongoDB.
Okay, so moving on to our next question. Why would you choose MongoDB?
Why would I choose MongoDB? Because, like I said earlier, Mongo has high availability and its performance is very high. Since it's written on C++, it's blazing fast. And also, the biggest and the best feature about MongoDB, as I see it, from an application design point of view, would be that it supports automatic scaling.
Okay, great. Okay, so does MongoDB provide transaction or logging?
Yes, it does transaction logging. There are, you mean transaction locking?
Transaction or logging?
No, it's very lightweighted in that way, and it's built to be so that it's extremely quick. So it doesn't have any locking per se. So that's up to your application code to manage that.
So we have one more question. How can I migrate my existing MySQL to MongoDB?
That was asked earlier, I think, by another person. So that's again, like I said, we can have we have tools that are listed on the MongoDB website.
So when do you use MongoDB than SQL?
Like I said, when we have the document-oriented, the very different types of data coming in, and a lot of unstructured data coming in, that's one indication that you would be better off with something like NoSQL.
Okay, so I think we have the last question for the day. Do I need a DBA?
No, you don't need a DBA for. It's not really required for MongoDB projects. A database administrator would not be required, but having said that, you can still have people monitoring the DB and the availability of the DB. You can still do that, and Mongo has a lot of automated ways also to do this.
So that's it. That brings us to the end of our webinar. Thanks for your attention. Thanks a lot, Uni, and this is all the time we had. Please look for a follow-up mail that will alert you on the on-demand status of the webinar so that you can review any material you missed, so that you can simply go over again. And a small request, we'd like to ask each of you to remain with us a few minutes longer and complete our 4-question exit survey. Now, any further queries will be taken offline. Reach us at our social media, or you can mail us at services@suyati.com. On behalf of Uni and the team at Suyati Technologies, thank you for joining us and taking time to attend our webinar. Have a great day.